Hello, welcome back to Maya. In this tutorial we're going to talk about a beginner's level introduction into animation, and with literally every animation tutorial out there, whether or not you're doing this animation in 2D or 3D, doesn't really matter. Everybody begins with a bouncing ball. In this case we're going to bounce a ping pong ball, okay, or a table tennis as we call it sometimes, right? We're going to bounce this ball across a surface, right? And this is going to explain a lot of the details about how do we key this animation, how do we set our keys for our transformation of one object in particular, in this case a ball. And other than that, we're going to play around with the graph editor to set some keyframes, but then interpolate between those keyframes based on a graph. Alright, so in our Maya environment, everything seems to be the same, right? There's nothing here. First of all, let's start by saving this file as something. This is always important. Save your files, always save your files. So let me go to Introduction to 3D Modeling. I mean, this is for a computer animation class, but I'm keeping my tutorials in the same folder. In any case, this is going to be bouncing ball animation _1 or something like that. Yours will be different. Add your names if you want. I'm going to further talk about, I'm going to give you a PDF file about how to name your files accordingly, because in a digital world, naming your files is very important. Okay, don't just do this. Okay, this is not a proper naming, because 2 days later you're not going to know what this file was all about. Okay, just go with a proper name, and especially if you are going to share this file with someone else, me or any other teacher or other students, or in the future your supervisor, your director, the person or the people you're working with. Name your files properly. Okay, let's save it. And I saved it as a, sorry about that, I saved it as a in Maya ASCII format. So Maya ASCII is a text editable format, meaning that you can open this file in a text editor such as Notepad, WordPad, whatever. And if there's something wrong with this file, if there's an error in this file, since it is text editable, you can find out what that error is in, you know, strange cases. This might be quite useful. And Maya binary is the compressed version of the ASCII. So go with the ASCII saving standard. Binary is usually smaller in file size, but since we're dealing with very small files, very small models, this is not necessary. Okay, go with Maya ASCII always. And in the future, if needs be, you will go with Maya binary. Alright? In any case, we have an empty space. We have our custom shelf with all the modeling tools that are necessary, and we're going to make one addition to it. But before we do that, let's go over what animation is in terms of the Maya environment. So as I've explained in the previous tutorial, there are some elements here that are not accessible if you're not dealing with them. Okay, if you're not working in animation, some of the menus that are available to you for animating stuff in Maya will be unavailable unless you activate them. Okay, in this case you can go to, for example, from this drop down menu to animation, and the menus will change. But even that will be sometimes not enough, and you will have to change your entire workspace. So my workspace is my own name. Okay, this is my custom workspace, and yours will be very similar. Mine is not that different from the original Maya, the modeling workspace of Maya, but you can set this to animation. And when I set it to animation, suddenly, you know, things will switch around. All right. I'm not going to work in this workspace because for a couple of reasons. One, most of you will be working in either low resolution, or not low resolution, but not 4K resolution monitors. Either you're going to be working on your laptop which is going to be in an HD resolution, or you're going to be working in a computer lab, which also has larger size but still HD resolution monitors. Okay, so your screen space needs to be really high, or at least if it is high, it's going to work to your advantage. So instead of using an animation workspace, I'm going to use my own workspace or the Maya Classic. Alright, doesn't matter. And instead of activating whatever editor that was just a minute ago, I'm going to put it here as a tool, and I can do that. Okay, once again, go to Display, go to Windows, Animation Editors, and while holding down Control and Shift, remember that's how we add things to our active shelf here. Okay, go to Graph Editor and pick it. Okay, other than that, I'm going to move this here, and how I did that, middle mouse button, click with middle mouse button and hold and move it around. And if you're wondering how I did these brackets here, that's these separators, these are called separators, to provide some visual comfort for separating the items in an order, you can click the external tutorial that I have shared. It involves some script writing, which shouldn't take too much of your time, especially if you follow the tutorial to the letter. It's like a 2 or 3 minute tutorial, I don't know. It's very easy, but you don't need to do this. Okay, these brackets are unnecessary for any work related purposes. This is just a visual comfort. This is just a visual item. Okay, it's for comfort. So you don't need these brackets, but if you want to know how to create them, go check out that tutorial. And it is an external tutorial, I didn't create it. Okay, so we need a graph editor, and a graph editor is something like this. It is just bunch of numbers on a graph, on an XY graph, and we'll come back to this. Okay, but we'll need it. In any case, once we look at this timeline here under our workspace, you'll see that it goes from 1, not 0, 1 to something like 120. Okay, and let's keep it at 120 for now. We can play around with it. And why are these numbers doubled? If we hold our mouse on top of them, you will see why. This sets the end time of the playback range. Okay, this is how much of the animation that you have created you are seeing at one time on your screen space, and this is the absolute range of that animation, the end time of that animation. You cannot animate a frame beyond this number, and this is pretty useful for in most of the time for everything, because in Maya we are not meant to animate like long sequences. Alright, we are animating certain actions that take up a short amount of time. This is not a non-linear video editor. Like, we're not animating an hour-long, say, documentary video about something. Okay, so, and these numbers are frame numbers. What is a frame? A frame is the amount of time that you are dividing a second with. So, for example, this is right now a 20 frame per second animation. 24 frames per second is the cinematic standard. Anytime you go to a movie, it is going to be 24 frames exactly per second. Alright, this is the cinematic standard. 25 is the European television standard, including Turkey. If you're watching television in Turkey or in Europe somewhere, doesn't matter, it's going to be 25 frames per second. And if you're watching television in America, for instance, or in Japan, for instance, you will be watching it in 30 FPS, or more specifically, this weird number, 29.97 frames per second. And the cinematic equivalent of that is 23.976 frames per second, but these are quite unnecessary in our time. I mean, go with an integer. This is an integer, tam sayı in Turkish. So go with an integer, like either animate in 30, 25 or 24, but believe me when I say 24 is the best standard out there, because you can easily divide a second into equal chunks. Like you can divide it into half, like you can divide it by 2, you can divide it into 3, you can divide it into 4, you can divide it into 6, 8 and 12. All right, so this is very useful. Like for example, 25 frames per second, you cannot divide it exactly in half. There is no 12 and a half frames. A frame is always one frame. There is no half frame. Okay, it is one frame and one frame alone, and however many of them exists in a second decides how fast your animation or how detailed your animation is. And 24 is the gold standard, to be honest. Okay, so go with 24. All right, so these are your frames, each and every single one of these, and we are not showing all of them, obviously. You need to get close, for example, or you can get close using this slider. Right now the range is between 1 and 31. Okay, and you can see the number is changing here. You can set it to the entire range, okay, 120. And these are your frames. Okay, you cannot move between these frames. There is no 16 and a half. It's either 16 or 17, right? And these are your frames, and we are going to lock our animation keys to these frames. We are going to decide on the speed of the animation and how it acts out in a certain period of time, how it performs in a certain period of time using keyframes. All right, and if you make a key on a frame, that is called a keyframe. That's why animation is usually referred to as keyframe animation. You're going to key the certain attributes and states of an object on a frame, and the rest of that animation will be interpolated by Maya itself. Let's demonstrate this. Okay, so what I need for this bouncing ball animation is very, very simple. Okay, I'm going to create just a plane, okay, a polygonal plane. Let me give it some width and height. Okay, 500 by 500. I don't need these subdivisions. Okay, it comes with 10 subdivisions in either direction, in both directions. I don't need them. I'm just going to lower them to 1, which means that it is going to be a single face. This is just a single quad face that happens to be a square because the width and height are the same. Okay, and I'm going to, you know, scale this in one direction, just so. I mean, it doesn't have to be exact or anything. And if you look at my grid settings, by the way, my grid settings are, as explained before, these units are centimeters, and my major grid lines are every 100 centimeters, which make these chunks, these large chunks, into 1 meter by 1 meter areas, and they are subdivided into 10 equal chunks, 10 equal segments, which make every single one of these areas that are defined by light gray lines 10 centimeters. Okay, and you can expand this grid size, and you can work beyond this grid size. You're not limited to this grid area. This grid is just for visual reference. Your imaginary world goes beyond. It goes infinitely, okay, or however large of a file your computer may actually record in memory, may save in memory. But in this case, 1000 in either direction. This is 1000 units, which means 1000 centimeters, which means 10 meters. 10 meters in each direction is perfectly fine for my purposes. Okay, just let's close this. Okay, and this is my ground, let's say, and I'm not going to touch this. Okay, and let's name this thing as well. Let's call it ground or something like that, and let's delete its history as well, and we're not going to touch it anymore. This is our ground, and we don't need to do any more than that. And then we need to create a sphere. Let me click the sphere, and let me scale it up a bit, or maybe I'm not going to even scale it up. I can do it right here. Just give it a radius of 50 or whatever. This is going to be a pretty big ball, like it's 1 meter in diameter. But I'm not too concerned about the sizes right now, because what I'm trying to demonstrate is the animation itself, the basic principles of animation. So I'm not trying to make this specifically a ping pong ball size, which is like, I don't know, 3.5 centimeters or something. This is not too big. I mean, this is 10 centimeters, so this looks like 3.5 centimeters, maybe 4. I don't know the exact standards of a ping pong ball. Maybe I should look it up. But in any case, I don't need to make this super realistic. Okay, what I need to do is give it some more subdivisions so this turns into a more uniform sphere. Right now, this object is being defined by the shape of this object, and the fidelity, the geometrical fidelity of this object is being defined by subdivisions, axes, and subdivision height. And subdivision axes is, I believe, yeah, these, let's say, imagine that this is Earth, these are meridians, and these are the parallels. Okay, so I have increased the subdivision axis to double the amount, which gives me uniform square shapes, square faces down in the equator. Okay, so that's what I did. I increased the density of the object a bit to make it more uniform, and that's about it. That's about it, really. So let me space out of this fully maximized perspective window, and I'm going to put it somewhere here. And in order to put it exactly where I want it, I'm using the pivot once again. But while I'm using the pivot, I'm holding down the X button, X, on my keyboard, and I'm holding it down so I can snap to these grid points. Okay? All right. So I'm here, as you can see, exactly at 350 away from the origin in the Y direction. Y is up in Maya. Okay, 350, that's good. And it's here. Nice. And I'm going to pull it back in this direction a little bit. And as you can see, the grid is infinite in orthographic views, but limited in perspective. Okay, that's how Maya works. So this, when you're changing the grid options here, these length and width only concerns this area, not the rest of the orthographic windows. We are only concerned with perspective when we're adjusting these units. In any case, let's go back. So maybe here somewhere, okay, or maybe here. Right? Yeah, -1000. Okay, -1000, and we are 350 above the origin, or the bottom of the sphere or ball. I'm going to keep calling it a ball. The bottom of the ball is exactly 300 centimeters away from the ground level that we have, the proverbial ground that we have created here. Okay, so what I need to do is, since I have decided the initial location of this ball and the initial dimensions, and I'm not going to touch them later except for animation purposes, I can just freeze transformations. Okay, this will zero out any of these transformations. Okay, translate will be 0, rotate will be 0, and scale will be 1 to 1. All right, my position is set. This is the default location of this object in this universe. All right, and then I'm going to do something else. I'm going to delete the history as well and get rid of that polysphere input and turn this into a fully editable mesh. I mean, it is an editable mesh, but I don't need this history anyway. In any case, what I want to do is animate this ball. All right, it is going to come here, jump, 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 and that's it. Okay, it is going, every time it jumps, every time it hits the ground, it will lose some of its inertia, so to speak. Okay, and it will go slower and slower, jump lesser of a distance and lesser. Okay, it will lose speed, it will bleed its speed, it will bleed its energy. Okay, and it will then roll away or something like that. Okay, so let's look at this. bouncing ball animation. So as you can see, both bouncing ball animation is the beginner level introduction to any kind of animation, especially in 2D animation. When you're drawing something frame by frame, you know, Walt Disney style, you will animate a ball, because the animation will dictate how fast this ball is perceived, what kind of transformation it goes through, and how it, you know, relates to the overall animation structure of this object in general. But you know, when you're animating a bouncing ball in 3D, it is basically the same principle, but in this case, instead of animating this ball by stretching it out, we're not going to be bothered with stretching this ball. We're going to fully accept the fact that this is a ping pong ball, and any stretching that might occur in this ball will be invisible to us. I mean, unless you're hitting this ball with such a force and recording that hitting moment so fast, you won't be able to understand the inner workings of this ball and how much it stretches and compresses in either direction, because this is a pretty solid ball. It's not like a tennis ball. And a tennis ball, it will stretch, compress, you know, turn into this elliptical shape, but this will stay mostly true to its original form. And we're going to go with that because it's simpler that way for understanding basic animation. Morphing the shape of a ball during the animation is quite harder. So we're not going to go with it. And instead, we're going to both animate the rotation of this ball and also its position across the space. Okay? And it's going to jump, 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 and then roll away. All right. So how do we do that? First of all, we need the graph editor. And remember, we access it from the Windows Animation Editor's graph editor. Control-Shift, click it to add it to your menu, and maybe change this location so it's next to the outliner, and we'll keep adding other menus in the future maybe. So, you know, keep everything properly aligned with each other, the necessary items. Anyway, let's open up the graph editor, and then before we look into this, let's minimize it to our corner here. Okay? And like I said, if you go to the animation here, you will see that it is docked in this window over the timeline slider, but I think this is a better use of space, you know, popping it up whenever it's necessary and minimizing it whenever it's not. In any case, how do we begin our animation? Let's begin by changing a few things. First of all, what I'd like to do is change this from 1 to 0. Okay? Let's change it from 1 to 0. So we begin with the 0 frame. And remember, this could be a minus frame as well. Okay? You can go minus in this direction. And there are some reasons for that, especially if you want to begin your animation from the 0, but then you want to keep it aligned to the proper time flow. Sometimes 0 time is time that occurs below the 0 point, before the 0 point, might be useful, but in this case we're going to begin with 0, 0 and 120, 120. Remember, one of these values is the ultimate length of your animation, and the other one is how much it is being currently shown to you on the screen. So if you play around with it, you're looking at just like 57 frames of a 120 frame long animation. Okay, that's it. So let's begin by animating just 1 second of this ball. In 1 second, and we're not trying to be realistic at this point or anything, in just 1 second, this ball is going to both touch the ground and come to a state in the air. Okay, right now it is beginning in the air. It is going to come forward, touch the ground, jump away from where it has touched, and then stay in the air at its peak point. Alright, let's go to 0. And what are we going to do? First of all, we're going to animate its direction. It goes in this direction, right? And it goes in this direction. So that means that we have to animate, translate X and translate Y. Okay, let's undo these. And then, since this is our beginning point, we're going to select both of these things, or you can just control and click on them. Okay, select one, control, hold control and click the other, and then right mouse click and say key selected. Okay, now as you can see, that translation property has turned in, just appeared with a red symbol next to it. And if you go to the timeline slider, as you can see, there's a red line on the 0 here, which means that this selected object, if you select another object or if you lose the selection, it's going to go away. This specifically selected object, and let's name this ball or something, okay, this has a keyframe or a bunch of keyframes right at this location. Okay, good. Now I am on the 12th frame now, and I can just go to 12th frame. And 12, since we are at a 24 FPS setting, 12th frame is exactly the middle of a second. Okay, it is half a second right now, and in this half a second I want to go somewhere like here, I don't know, 250, and I'm holding down X to snap to the grid, and my grid is every 10 centimeters. So when I'm pulling in this direction and holding X, I am snapping to the grid, and I'm going to come over here, right? I'm not touching the ground yet, and there you go, I'm touching the ground. And since my ball is 50 centimeters in diameter, and I was away 300 centimeters from the ground, 350 centimeters above the ground originally. So if I go minus 300, the bottom of this ball is touching the 0, and my plane is at 0. If you look at here, okay, right now I'm perfectly touching the ground. Nice. Okay, and I'm just telling you how to do this kind of thing by snapping to grid and everything, because it's good to learn about how to use the grid and snap functions of Maya, because it's going to come in handy later on. Right now you can just animate it like without proper values or anything. I mean, it could be values with decimal points, doesn't really matter, but for simplicity's sake and for, you know, taking advantage of Maya's snap functions, we better go with integers. All right, okay, so I did this animation, but if I go here, it's going to reset because I didn't key this anyway, so I need to key it. Okay, let's go and key it. Right, okay, I'm going to do the same thing again. Select these both, key selected, and right now Maya for this object has set 2 keys, and the rest of this information is completed by Maya. Okay, and they are moving in a sort of linear, but with some kind of ease in function. I mean, it's picking up speed and it's slowing down just a little bit, but Maya is automatically connecting any other non-keyframed information at these on these frames by interpolating between these positions. Okay, let's forget about that for a second. Go to the 24th frame, go to 500 and raise to 0 again. Okay, and again select these two and key selected. Now if you watch the animation from the beginning, that's it. All right, now does this ball look like it is bouncing? No, it looks like it is skipping. It looks like it is flying. It is not actually imparting, or it doesn't look like it is imparting any of its energy to the ground, or it doesn't look like it is reacting to that impact with the ground. That's why bouncing ball animation is important, because you learn about this stuff. So what I need to do is to imagine a ball. Imagine how a ball reacts. It flows slowly and then it touches the ground and immediately bounces back. That energy is almost immediately translated in the other direction, but the fall is ever so slightly gentle and it picks up speed. Once it touches the ground, it immediately reverses in the other direction, almost immediately reverses in the other direction, but when it reaches its peak point, it slows down again. So that's basically what we need to do. But in addition to this, I'm dropping this ball. Oops. Let's forget about this one. I have another ball. When I drop it, I'm dropping it vertically. But in my case, I am also trying to animate it as it moves in a certain direction. Okay? So I need to do this. Basically, I need to come down, hit the ground, and move away from it by picking up some height. Okay? So I need to do that. But how am I going to do that? Do I really have to go to every keyframe and set its position for every frame that exists in the second? No. But, you know, traditionally speaking, that's what you should do. If you are Walt Disney and you're drawing these animations, you have to draw every frame by hand. But that's not how we do things in 3D animation. In 3D animation, we tell the animating software how we want the interpolation between these keyframes to be calculated. And that's why we need the graph editor. When we open up the graph editor, with the object selected, if there's no object selected, it's going to come in empty. So select ball, okay? And any keyframed, like these are keyframed, translate X and translate Y. Anything that is keyframed is going to turn up in this graph editor, okay? And we are seeing both translate X and translate Y. Y is the height of the ball, and translate X is the linear direction of it, the linear position of it. We can see both of them side by side and in this graph next to each other. Okay, so right now I'm not interested in the linear speed of this thing. I'm interested in its height. So let's go to translate Y. Okay, and as you can see, the ball is losing altitude slowly at first, but when it reaches the ground, instead of impacting it with full force, it slows down. So it skips the ground instead of just hitting it sharply, hitting it bouncing. So that's why we need to, you know, fix this. To demonstrate the differences between these types of interpolations, I'm going to select all of these keyframes and turn it into a linear tangent. Okay, now watch it. Okay, the speed of the ball in this direction is not linear, so it is just doing that weird thing. But let me make it linear as well. Let's select both, make both linear, like everything is linear right now. The speed is not changing at all. The speed right now, the speed is constant. Okay, the linear graph means that the speed is not changing. This graph is not about speed, but it's about the position of this object in 3D space. But if those positions are connected to each other, these two separate keyframes in the timeline are connected to each other with a line, with a straight line, that means the speed is constant. It's not changing. So in both translate X and translate Y, both in the horizontal direction of this ball and the vertical, you know, horizontal movement and the vertical movement of this ball, the speed is constant. So let's watch it. As you can see, the ball is just coming down, you know, bouncing off. This is linear interpolation, okay? Everything is linear. I need to be here, I need to be here. The shortest path I can take in this amount of time is this. Just whoop, whoop, that's it, okay? So, but that's not what we want. So again, we're not going to touch translate X for now, but we're going to play around with translate Y. All right, so when we get into translate y, what we need to do is this thing to begin losing its altitude slowly, but then ever increasingly. But when it touches the ground, the middle point of this animation, we need it to, do it very sharply and immediately change directions. After touching this point very sharply, we need to change its direction immediately in the other way. Okay, so let's do that. First of all, let me select these two and turn them into this auto tangents. Okay, so Maya is automatically easing out this animation from this keyframe and easing in to this keyframe. Okay, it's just smoothing it out, just smoothing that animation out. But this point is still sharp. Let's check it out. Better. It's better. We're not there. By no means. We're not there yet. But it's better. Okay? It needs to be sharper, and the ball, with the amount of speed that we're talking about, has to, lean in with a lot of curvature. Okay? Let's check it out. Now, let's don't forget to select the ball. Let's go to translate Y again. Okay? We need to keep this sharper. Now, as you can see, there are two ears, two, handles on either side of this thing. But when I touch one and try to, change its rotation and position, both of them move at the same time. This is not what I want. So I want to break off these two things separately. And in order to do that, I'm going to touch this, break tangents. These are called tangents, and each keyframe has one for going into this keyframe and one for going out of this keyframe. Okay, and I'm going to break the relationship, the angular relationship between these tangents. Okay, and now they are broken, right? So I can do stuff like this. All right, let's check it out again. Not bad. Good. All right, let's go back to the graph editor, and I'm going to show you something else. Instead of using these arrows, these tangents as we call them, in a fixed length, we can also play around with their length as well. But when I try to grab them and pull them, I want to pull them in this direction so I can change the curvature of this graph. I cannot do that. In order to do that, I need to, use free tangent length. And free tangent length seems selected, but when I click it, Maya gives me an error. All of the animation curves are non-weighted, meaning that they have no weights. And these keyframes carry no weight, and I want to change that. So I'm going to grab both translate X and Y, and I'm going to do this later for other keyframes, for other transformation properties that I might add from here. I'm going to do the same thing to them. I'm going to go to where I was going. Sorry, I usually forget this kind of stuff. Yeah, go to curves, and under curves, select weighted tangents. Okay? Now, when I go to weighted tangents, let's go to translate Y again, select this one. Oh, would you look at that? Now they have their own personal weights, which means that I can not only, move this, change its angle as it approaches the keyframe, but I can also play around with the curvature. Okay? This is very useful. I can play around with the curvature of this thing. So I can do something like this, for instance. And this, for instance. Okay? Alright. And I can do the same thing for these as well. Yeah. Let's try it again. Okay, very good, very good. We're getting somewhere. All right. Now, this is good and all, but I need to keep adding to this animation, and every time it touches the ground, it is going to lose some of its speed. It is going to lose some of its height on the next bounce, because we want to impart the idea that this ball is losing energy, like it would in real life. Like when this ping pong ball hits my table, this is the point I'm dropping it from, it is not returning to its original position, and it is very hard for any object. I mean, they have to be really perfect. They have to have from a materials and physics properties, from a physics perspective, they have to conserve their potential energy so well that after touching the ground, that they should return to their original states. And it's very hard for an object to do that perfectly. Conservation of energy is an inescapable reality of our universe, but so is the entropy of energy. Every time this ball touches the ground as it bounces, it loses some of its energy to be never regained. Okay? Our universe is a high entropy environment. Every time we do something, we exert energy, that energy dissipates. Same goes for the bouncing ball. So we are trying to replicate that reality. Okay? We can replicate it in a cartoonish manner, like in a Walt Disney cartoon, a Walt Disney animated movie, or we can do it as realistically as possible in a 3D environment using simulations and stuff. But we are trying to replicate that reality, and the reality states that once this ball starts bouncing, it is going to at some point stop. Okay? And while it is getting closer and closer to stopping, it is going to lose its energy, bounce lesser and lesser distances, go slower and slower as it bounces. Okay, so let's do it. How do we do it? First of all, our first animation cycle, let's say, coming from the peak point, touching the ground and getting to the next peak point, it took 1 second. So common sense suggests that if in the next cycle I'm going to go slower and I'm going to lose height, then that means that this is all going to happen in less amount of time. Okay? First of all, the second cycle of this animation is not going to take 24 frames, which is 1 second. Maybe it is going to take something like 20 frames. Okay? It is going to be faster. And not only faster, it is going to be the distances, the translate x and y properties will also change, but we can edit them later. So instead of playing around with keyframing these, what I suggest is, first of all, select these two keyframes, okay, Control C to copy them, and then go to the next ground hitting point. Okay, so the next ground hitting point should be around the 36 frame mark. If everything is ideal and this ball is not losing any energy at all, the next time it touches the ground will be 12 frames later. 24 plus 12 is 36. Okay, and the important thing is I'm right now snapping to time. Time snap is on. So I'm not going in between the keyframes. Okay, I want to stay on the keyframes. Time snap is on. So I'm going to hit Control V, and Maya will automatically add those same keyframes and also obviously connect these two keyframes to each other. I don't have to select the first one because the first keyframe at the 0 here, I'm not going to select it. And by the way, I can pan just as I'm panning in the perspective window. hold down Alt key and just use the middle mouse button. Okay. I don't have to add this keyframe to this location because whatever keyframe is the last, Maya will automatically interpolate between the one that you have just added and the last one that existed before its addition. Okay, so this is good and all, but what did we say? We talked about how it will take less amount of time. It will be shorter in distance in both height and linear distance that has been accumulated. Okay, so I need to carry this down. Okay, and I also need to shorten this animation. So maybe let's go to shortening this by 3 frames in either direction, so 6 in total. So the first animation took 1 second, the other is going to took like 18 frames, so that is 1/4 of a second shorter. Okay, and since I went 3 frames in this direction, I need to put this 6 frames on the other direction, so 42. Let's see, 42, right? And I'm also going to bleed speed as well, bleed height as well. Okay, and now the fun part begins. I need to adjust these things. Oops, sorry, I select all of them. Okay, maybe I should break this as well. Break the tangents so I can control them separately. Like so. This is still a little sharp, perhaps. Oops. Just make sure you select one keyframe, not the whole thing. Okay, I sometimes make that mistake. And then maybe do this, right? And this is pretty messed up. Let's fix that. Okay, that's good. What's next? I need to keep repeating this, so I'm going to select these two, and remember we had 9 frames, right? 32 to 42. So maybe it is going to bleed more speed in the next cycle, so it's going to go 3 frames less from the peak point to hitting the ground. So that gives us 6 frames, so from 42 to 48. All right, and this will also go like 6 frames less, 3 from the previous cycle and 3 in this cycle. So 1, 2, 3, 4, 5, 6, right? 52. So this is 48, 52. Maybe I'm calculating this wrong. Let me check. So this is 9 frames. These are 9 frames. Oh yeah, so it needs to bleed speed. Okay. And we didn't bleed speed as well here. Okay, this is 12 frames. This is 12 frames. So we're not bleeding speed in the linear direction. Let's forget about that. So I'm going to just lose those 3 frames from 57 to 54. And I'm going to lose height. Okay. This one I want to break the tangents again to fix any issues. Oops. Maybe I'll also start playing around with these curvatures so they look better. Now I'm trying to create these types of perfect looking paths, basically. I'm fiddling with these things. And finally, let's check this out. Maybe here. Okay. And then what else? I'm copying and pasting these, and every time I paste I'm losing speed. Let's lose some more speed. Okay, and let's lose speed as well here. And finally, select this. Break those tangents. Play around with those settings. Make sure they're as smooth as possible. Copy these, paste them again. I mean, it takes some time, but you can see where this is going. We're trying to stop the ball by bouncing it and losing its energy over a certain period of time. Okay, it takes some getting used to, but it's really fun. Okay. This is good so far, so let's check the result. Oh, by the way, there's one more thing. As you can see, we have set the direction, the height of the ball, but we never touched its linear movement. We didn't talk about how the ball will move in this direction, right? So that's a problem. We need to fix that. Our animation goes all the way up to the 74th frame, but when we add our translate Y on this, right, it just ends its movement right here on the 24th frame. So that's a problem. So how am I going to fix it? First of all, I'm going to delete this middle keyframe, and then I'm going to carry it all the way over here, but this is only going to fix the time issue. Right now, the movement of the ball from 0 to like 500 didn't change, but we have set that 500 for this cycle only. So it has to go some extra distance, not exactly like 1, 2, 3, 4, 5, 6 times of that distance. Ever so slightly it will lose its inertia in that direction as well, but it has to go further away from the 500. So let's, for simplicity's sake, let's say for now that this is not 500, but some like 1000. Okay? And in addition to that, it is going to lose speed. So how do you make something lose speed? How do you make something go slowly and slowly over time? Well, before we touch that, let's forget about it and watch this animation and see how it unfolds. Not bad. Now, does it really have to lose more speed than this? Because every time it touches the ground, it goes shorter of a shorter distance. Every time it touches the ground, the next time it will touch the ground will be in a shorter distance. So the overall linear speed in that direction, in the x direction, right? This is x. In the x direction, relative to how this ball bounces, is getting shorter and shorter already. So we don't have to do anything. We can just, you know, aside from maybe a few tweaks, and I don't see it necessary at this stage, at this level of animation, we don't have to touch anything. Okay? Maybe slightly more distance than 1000, like let's maybe put this to 1200, maybe. And we have to put it, you know, here at the exact point. Go back. Nice. Nice going. So let's finish this animation. I'm quite happy with how this is turning out. So let's keep adding to it and finish it somewhere, you know? We have to end this animation somewhere. Oops. We've already broken this. Okay. So you see, we have come to a point where staying in these perfect frames is getting harder and harder. Now Maya will give you the ability to, you know, divide this animation into single frames, because that's what it has to do in the end when you're rendering out something. For example, if you're doing this for visual effects purposes, say that you're doing a Pixar movie and you're animating your Buzz Lightyear or whatever that character is, whatever the name of that character is. In any case, every frame will be rendered out as a single image, but the animation keyframes can stay between these keyframes. Okay, so Maya will only take the 64th frame, for example, how this state of the animation exists as it is interpolated at the 64 frame mark, but your keyframe doesn't have to stay there. It can just go here. If you want to, you know, adjust these things more specifically, okay, you can do that. And this is going to help out quite a lot. Okay? But this is for, you know, you shouldn't animate like this if you're not adjusting something to be the final animation. We always want our animation to be as precise as possible in the timeline slider. We want to work with real frame numbers, but anything in between, as these animations translate into each other, like this bouncing ball animation, we can go between the frames. But this is just a mathematical way of drawing this curve, basically. You're trying to draw this curve to tell Maya to render for you the animation, but it is going to render at the 64th frame mark. The animation you're going to get will not be at this keyframe. It's either going to be at 63 or 64. Okay? The image that is going to come out of Maya in the Playblast window or in the V-Ray render, whatever, or when it is baked out to individual keyframes and sent out to your favorite game engine like Unity and Unreal or whatever, it is going to be at these marks. Okay? Not here, not on this keyframe. But for controlling the animation curves, the graph, so to speak, of how these keyframes are interpolated, how this information is carried out from one keyframe to the other, you can animate between the frames. Okay? But do this carefully. In any case, let's finish this, shall we? Okay, let's put it here somewhere. Okay. Let me turn on snap again, put it here, put it here. This is going to be like so. Turn on snap again. Small adjustments, that's all it is. That's all it takes, small adjustments. Okay? Now we have come to a point that, check out these values. Like this is the 300 range, right? And we have lost some ground here. I mean, these are all have to be at the 300 range. This has to be at 300. Minus 300, that's what I mean. And I'm also snapping to the values evenly. Value snap is also turned on, so it is snapping to integer values. So for example, this is like minus 301, this is minus 300, okay? That's what's going on here, okay? Okay, almost there, almost there. Okay, and then finally, let's get these. Go over here. Play around with the settings a bit. And then do this. Okay, then just add one more keyframe here somewhere. Let's keep this linear, okay? And then just do this. Some like this, okay? Maybe increase it to, I don't know, 86th frame. Okay, that's good. Okay, Control S to save your file. Let's go back. So as you can see, we have animated all the way to the 86th frame. Oh, sorry, forget about this. 86th frame, but as you can see, our translate X function, translate X animation is still at the previous state, the 74th. Let's go to 86, carry it all the way over here, maybe increasing it to like a little more distance. Let's check. Nice, good going. And just for funsies, we can keep elongating it. Like all the way to 120 frames, because why not? Okay, and make sure that this stays at 0. And this shouldn't ease in, it is still hitting the ground sharply. It should still hit the ground sharply. So some like this. Okay? But instead of jumping over again, I am zeroing out the animation here. I could keep going infinitely. Okay? I have to stop somewhere. Okay, so instead of going linearly in this direction, I'm going to copy this keyframe, put it at the 120 mark, and then do some like this. Okay. I want this thing to stop at 120, and I want it to ease into that moment. Okay. And when it's going to ease into that moment, when this animation ends around here somewhere. Okay? Around here somewhere. So until then, I'm quite happy with things going linear, but then it is going to ease out. Okay? That's good. So what is happening here is basically, we have been thinking about the height of this object for quite a long time. So let us remember what is going on behind the scenes. The linear movement of this object in the x direction is constant. Okay? No matter how much it bounces or in how short spans it bounces, skips from the ground, its linear speed is constant. But then after it stops bouncing and starts rolling, I want it to stop finally at the 120th frame mark. Okay, and maybe this is slowing super fast, so I don't like this, so I'm going to give it, do something like this. But basically the speed is going to be linear, then it's going to ease out or ease in to this 120th frame mark. Okay, let's check it out. Okay, nice, really fun, right? So what is the one final thing we can do? We can actually roll this ball. We can rotate this ball. So in order to do this, let's Control Save. And how do we rotate it? We want to rotate it forwards. Okay, I want the ball to rotate forwards, and in this direction. I want it to rotate as it bounces, but it's going to stop at some place as well. So, but when you look at the rotation, it is in the minus direction, because rotation, counterclockwise rotation is plus, and clockwise rotation is minus. Okay, that's how the 360-degree rotation wheel works in mathematics and in Maya's animation standards as well. So in any case, let's zero this out, key this, go to, I don't know, here somewhere. Let's keep this simple. I mean, we want it to be at, at this 82 second mark. We might want to animate the rotation of that ball again. So maybe until then, let's tell this ball to rotate 2 or 3 complete rotations. Okay, so one complete rotation is what? 360 degrees, obviously. So 360 degrees times 3 is 0, so it doesn't want to hear that. So what is it? 720 plus 740, sorry, no, 720 plus 360 is minus 1080. Okay, so minus 1080. This is pinkish hue, which means it is not keyed. Let's key it, make it red. Okay, and then around here somewhere, let's add it, let's give it one more turn perhaps. I don't know, maybe 200 more degrees, 240 more degrees. So 1280, that's good. Keyed is selected. Okay. Okay, but I want to ease in this animation just a little touch. Okay, I want this rotation to be linear just like the movement. So I'm gonna give this a straight tangent, but this is good. This just eases out a bit. Okay, this is good. And if I want to give it weighted tangents, again, rotate Z selected, go to curves, select weighted tangents, and this will allow you to play around with these weights of the curvature of this graph. Okay, let's go back to beginning. Nice, isn't it? Right, and that's it. Basically, this will be your first animation. Now you know how to control keyframes of objects and how you can edit the interpolation between those keyframes in the graph editor. Now it takes getting used to, obviously, like with everything, but basically this is the time, these are the values, and these are how all of your keyframes are interpolated to each other across time. And this is how it's going to be for all of your animation workflow. Okay, doesn't matter if you're doing bone and skeleton animation, doesn't matter if you're animating doors or characters, doesn't matter if this is a looping animation or just something standard. It is always going to be like this. It is going to be explained and, you know, composed through graph work. All right, using keyframes and telling Maya or telling your favorite computer software how these keyframes are connected to each other. And finally, you might be asking, okay, I did my homework, I've done my assignment, I'm the best, how am I going to send this to my teacher? Well, it's very easy. You go to animation, okay, and under the playback, you will see something called Playblast. Playblast is used across the industry. Doesn't matter if that is VFX production or video game design or visualization of any sorts in the 3D environment. Playblasting means that before we get the final renders, before we get to the good stuff, you know, the good looking stuff, we need to tell our peers, we need to tell our team members or our supervisor or director or whoever, in your case, your teacher, how this animation acts out in the viewport. Okay, Playblast is basically what I'm doing right now to give you a sample of this information. I am recording my screen, right? I am streaming to you my screen almost. Playblast does that, but for the viewport. So go to Playblast, but don't just click it, go to its menu, okay? It asks you a couple of things like, okay, so this is the time range. What do you want with it? You want to start and end or the time slider. So the time slider is right now set to 120. So you might want the time slider if you're using the entire time slider, or if you're using a specific part of it, like if your animation ends at 100 instead of 120 or 140, you can just type it in here. I'm going to be typing in 120, but remember we have begun at the 0 point, so I'm going to start the time from 0. This is important, okay? Or you can use sequence time, whatever. And view, show ornaments. Show ornaments, I think, are these poly counts. I'm not too sure. And then I don't want the multi-camera output. I'm not rendering off screen. Format will be AVI. If you select image, it's going to be a bunch of images. Okay, then you have to, you know, join them together to create a movie, and that takes time. It's not necessary. Pick AVI. These are very old codecs. Just click none, quality 100, display size, get it from window. My window is pretty big. Make sure, by the way, that it shows all of your animation in a neat fashion. Okay, right now my animation is playing out in its entirety in this viewport, and I'm sure of it. Okay, because it is going to render this viewport, and my scale is going to be 1. I am rendering it in its entirety. Once again, remove temporary files, frame padding. Let's see what it says. I don't know what frame padding is. Let's check. Maya frame padding. Playblast. When we say ask Google, this is why. Okay? This is a complicated software. You cannot know everything about it. For the image format, specifies number of zeros. Okay, I get it. It's not necessary. We are not interested in frame padding because we are just rendering it out as an AVI file. If it was an image, means that it was going to be an image, bunch of images, like added for every frame. Then Maya is asking you how many numbers you want behind each of the file name to tell you how many frames there are. So frame padding is that. Just forget about it. It's even hard to explain like this. Okay, save to file. Movie file is, I don't know, bouncing ball animation, Playblast, and yours should contain your own name, right? This is for my tutorial only. Browse to select the location, for example, fastest courses, introduction, tutorials, Maya 3, this is good. Please select this. You're gonna need a name, right? Come on. Animation, Playblast, save. Thank you. And when you say Playblast, it is going to render it out. There you go. That's it. You have completed your first animation and Playblasted it and turned it into a movie file. Now you're ready to share your MA file, which is your Maya file, and your animation in Classroom. So I knew you did your homework. That's about it. Let me check if everything is all right in terms of, you know, file size. Maybe it's too large and too unnecessary. I don't know. We're gonna see. Maya 3 anim, bouncing ball. Holy shit, it's 1.3 gigabytes. Yeah, forget about it. We're going to render it with an encoding. Nice. So here is your settings. TSCC. Let's do the quality thing. Yes, overwrite please. We'll see how good it is. It is good, and the size is very small. Okay. Whew. We have fixed this issue. Sorry about that. This usually isn't a problem. Basically, I'm going to write this down on the homework assignment sheet as well. Anyway, this is how you do the bouncing ball animation with the jumping and skipping and the movement and the easing out and everything, and this is how you render it. And basically, everything, every animation from this point forward that you're going to complete for this course will also be playblasted in this fashion. Basically, Playblast settings are AVI, TSCC, quality 100, scale is 1. Make sure your viewport is large enough to both render out. I mean, don't do this very small viewport like this, okay? And make sure that it encompasses the entire animation. That's about it. Good luck. Bye.